I'm Joanie, your Geospatial Data Analyst. Today we're going to explore the fundamental concept of geospatial data in agriculture. Whether you're new to working with spatial data or looking to refine your skills, this session will walk you through all the essentials from handling vector and raster data to performing spatial operation and of course exporting the results. By the end, you'll have a solid foundation on how to apply these techniques in your own project. Let's get started. I listed you here all the important packages that you need to be aware of to working with spatial data. First, you have the SF package, which is useful to handling vector data. Terra, of course, for raster data. Stars can be useful to handle multidimensional raster data. Tmap and ggplot are good for visualization or creating maps. Tidyverse, of course, for data manipulation, and leaflet can be really useful to create interactive maps. The first step in any good spatial data handling workflow is to read the data. First, here we're going to start with the vector data. The SF package gives us a function that's called stread, with which we can read shapefile. So here on my computer in the data folder I have an mrc-s shapefile that contains a simple feature collection with 10 polygons. So if I want to know the name of the column of that simple feature, I can just use the name function of my vector data, and here I get my two column name. One is always geometry, which is the coordinate of the polygon, and the other one, in this case here, in some kind of an ID column in which we have the name associated to the polygon. We can plot this vector data with the plot function. So here you can visually see my 10 polygon and their ID just here. There's many things that we can do with vector data. One of the most common operation is to create a buffer. So creating a space around the polygon for many reasons. So here I got you an example. If I take my vector data, so my collection of 10 polygon, and I choose the one which contain Le Binaire in its ID column, I'm getting only the blue shape here. I can choose to add a buffer with the stBuffer function and specify a distance. Here, no matter the CRS of your polygon, the distance is in meters. So I choose to add 1 kilometer around my polygon in blue. And here I give you the code that I use to create this image to show you what I mean by buffering a polygon. So first I started by extract the Le Binaire polygon from my vector data, and I call this special feature Le Binaire. With the ggplot function, I now added my buffered polygon, so the one with the buffer of 1 kilometer, and I tell ggplot create me a form in red. So that's my first layer. On top of that, because I want to see the difference, I want you to see the difference, so the 1 kilometer added around, I tell ggplot add me a layer, use the data, so the spatial feature called Le Binaire, and fill this shape in light blue. And using the time minimal allow me to simplify the axis here. So this is a good way to see that my red polygon, which is the one with have a 1 kilometer buffer around the perimeter of it, underneath the blue polygon, which is the one that we have in our shapefile. Now, spatial data comes also in form of raster data. So here I call the rast function and I tell him, look in my data folder and read this diff file. If we print this spatial raster, we're going to have a spatial spat raster object with a set dimension, resolution, and extent, and a given CRS, which gives us the name of the measured value with some minimum and maximum value, and here an extract from a time series. So we have one more information which gives us a date. Now, if we put this raster data, we are going to have this kind of image. So I don't know if you recall, we have exactly the same shape of our 10 special feature object. But in this case, we don't not only have the shape, but we have a raster data in which every little square of information represents a value. So all the light green and near yellowish color represent a mean temperature of 9 degrees, and all the little square that are more like bluish or darker blue color represent a mean temperature of 6 degrees. Again, there's many operations that can be done with a spatial raster. Some common one here, because we have some kind of temperature information, is to extract the mean. So if I want the mean of every little square of information here, I can just call the global function. Tell this function that I want to look into the raster data, extract the mean, and remove the NA. So everything that is around my desired shape won't be considered. Now that I have this mean, I can use it to compute some kind of anomaly information. So if I take this raster data and I subtract the mean, I can now have a spatial raster of anomaly. So here, instead of having 9, we have all the green, the light green and the yellowish color represent an anomaly of +1 degree, and all the blue is not 6, but now represent an anomaly of -2 degrees from the mean. One other very useful function for raster data is to extract the value. Having all the information about the temperature in form of a spatial raster is useful, but sometimes we need to transform this spatial raster data into a data table format. So the proper way to do it is to use the extract function from Terra, gives it the raster, the vector data, and add a couple of other information. Here I want to extract the longitude and latitude value, and I don't want any kind of ID value. So this function gives me a data frame, and if I'm extract, or if I want to see the summary of this data frame, that gives me a data frame in which I have longitude, latitude, and a temperature column with individual data. Of course, we often have to export our work. So if we're working with vector data, the SF package has a stwrite function in which we can specify the vector data that we want to export and gives it a path and a name. So this will write the vector data on my computer in the shapefile format. We can do exactly the same thing with raster data. So the terra package has a write raster function that works exactly in the same way. So we can specify the raster that we want to export and gives it a path a file name and a file format. This will also save on my computer in the data file, a diff file containing everything that I had in my raster data. So, this chapter introduces fundamental spatial data operation in R. You learn how to set up your environment, load and visualize vector and raster data, and perform some kind of spatial operation, and of course, export the result. In the next chapter, we will explore advanced geospatial analysis technique, including spatial modeling, machine learning with geospatial data. So, if you got any question or thought about this topic, drop them in the comment below. I'd love to hear from you and help out however I can.